Hi all, I welcome all of you once again. Here I am Sudhi, and today I am with a very small topic, law of chemical combination. And I hope that this video will be helpful for those who have completed already 10th standard. And let's see what about the first concept of our topic, law of conservation of mass. See, you might have heard about law of conservation of energy in lower classes. You know, energy cannot be created nor be destroyed. Similarly, whenever we are considering a chemical reaction, let me write one chemical reaction. Capital R gives P. You know, R for reactant and P for product. See, during a chemical reaction, mass of the reactant must be equal to mass of the product. If mass of the reactant is equal to mass of the product, then you need to say that reaction obeys law of conservation of mass. So let us see with the help of two reactions. See, I am just writing first reaction here. Nitrogen combines with the hydrogen to get ammonia. Similarly, we have the next reaction. Here we have N2 plus 3H2 gives you 2NH3. See to the difference? Here, this reaction is not balanced, but here you can see that this particular reaction is balanced. See, what is the purpose of balancing chemical reaction? That can be well understood by this example. See to that. I am just saying what is the mass of this nitrogen. You know, the mass of nitrogen is 28. Mass of nitrogen is 28. What about mass of hydrogen? Mass of hydrogen, you can see that 2. Now, what is the mass of ammonia? Nitrogen has a mass of 40 and hydrogen has a mass of 1. So that you can write hydrogen, ammonia mass is 17. So let's calculate what is the mass of the reactant and what is the mass of the product, and let's analyze whether these two are equal or not. So then, if you find mass of the reactant will be equal to 28 plus 2 equals 30 here. And what is mass of product? In this case, we have mass of product equals 70. See, here we have mass of the reactant equals 30. Mass of the product equals 70. Obviously, you can see that these two are not equal. So, if these two are not equal, then this reaction is not obeying law of conservation of mass. See, this equation do not obeys law of conservation of mass, since you know that mass of the reactant is not equal to mass of the product. And once you see the next side reaction, you know that reaction is balanced. See, what is the purpose of balancing? Let's see to that. Here nitrogen, what is the mass of this nitrogen? It's equals 28. And what is mass of hydrogen? It's equals 6. So why 6? Because one hydrogen molecule is 2 and we have 3 hydrogen molecule, so that total we get 6. And we have ammonia. What is the mass of ammonia? One molecule of ammonia is 17, so we have 2 molecules, so 2 into 17 equals 34. So let me write there 34. Now, let's verify whether the mass of the reactant is equal with the mass of the product. So what is mass of reactant? See, mass of reactant, you can write 34. Mass of reactant is equal to 34 and mass of the reactant is equal to 34, mass of the product is equal to 34. So in this particular case, you can see that mass of the reactant is equal to mass of the product. Means this obeys law of conservation of mass. So we are talking about law of conservation of mass. What is the statement of law of conservation of mass? during a chemical reaction, mass of the reactant must be equal to mass of the product. Here I have shown one example. See, N2 plus H2 gives ammonia, and you've seen that in this case mass of the reactant is not equal to mass of the product. So this is not obeying law of conservation of mass. But you can see this particular reaction. In this case you've seen that mass of the reactant is equal to mass of the product, which means this reaction obeys law of conservation of mass. So if any reaction is obeying law of conservation of mass, then that should be properly balanced. If that equation is not properly balanced, then it is not obeying law of conservation of mass. Say for example, I am just writing one reaction here. H2 plus O2 gives you H2O. Say to this reaction, and now just by looking at this reaction you can say whether this reaction obeys law of conservation of mass or not. See, in this case we have a 2 hydrogen molecule, 2 hydrogen atoms here. Here we have 2 oxygen, but on the right hand side we have only 1 oxygen, which means it's not balanced. If it is not balanced, it's not obeying law of conservation of mass. And I'm writing another reaction there. We have a 2H2 plus O2 gives you 2H2O. In this particular reaction, you can see that here equation is properly balanced. If the equation is properly balanced, then it obeys law of conservation of mass. So that's regarding law of conservation of mass. So let's talk about the next law of definite proportion introduced by Proust. See, what is this law? So if you want to talk about this, first of all, let me talk about myself. See, I'm a great fan of Mr. Dhoni. The way how he walk, how he bat, how he speak, really that is extremely different from the way how Mr. Sachin talks. So each person has their own personality. Similar to that, when we apply this concept to chemistry, see, I am considering one molecule H2O. You know water? It contains 2 hydrogen atoms and 1 oxygen atom. See, I can prepare this water from rain, or I can get this from rain, or I can get this from well water, or even I can prepare this by chemical methods, hydrogen plus O2. See, whatever the way you prepare this compound doesn't matter. If you want to say this is water, it must contain 2 hydrogen and 1 oxygen. But instead, suppose if I am writing here H2O2 and I am trying to teach you this molecule is water, you people won't accept, because you know water do not have the ratio of hydrogen and oxygen 1:1. So if we get such a ratio, then definitely you will say that that's another compound. So this concept is called the law of definite proportion. What is meant by law of definite proportion? A compound contains fixed element in fixed proportion by their weight, irrespective of their method of preparation. So let's talk about the next law, law of multiple proportion introduced by Dalton. See, in order to explain this, I am considering 2 elements. You know, first one is carbon and next is oxygen. So carbon and oxygen can combine to form carbon monoxide or carbon dioxide or carbon suboxide. But here I am considering 2 compounds. First one carbon dioxide, second one is carbon monoxide. So carbon and oxygen combine to form carbon monoxide. This is first molecule. Similarly, carbon and oxygen combine to form second molecule. Let me say here carbon dioxide. So the first molecule is carbon monoxide and the second one is carbon dioxide. See to these 2 compounds. In these 2 compounds, you can see that carbon mass is fixed. What is the mass of carbon here? Here you know mass of carbon is 12. In this case also mass of carbon is 12. Means mass of carbon is fixed. Then what about the mass of oxygen in first compound and second compound? In first compound you can see that mass of oxygen is 16, whereas in the second compound you can see that mass of oxygen is 32. So I am just taking the weight of oxygen in the first compound. What is weight of oxygen in the first compound? I am writing first compound oxygen is to weight of oxygen in second compound. Weight of oxygen in first compound is to weight of oxygen in second compound. What is that? 16 is to 32, which you get 1 is to 2. So what is this ratio? Ratio of oxygen that combines with fixed weight of another element. The ratio of one of the element that combines with the fixed weight of another element. That's the ratio. So what is meant by law of multiple proportion? When two elements combine to form more than one compound, then the ratio of one of the element that combines with fixed weight of another one bears a simple whole number ratio. Once again, see to that. When two elements, carbon and oxygen, combine to form more than one compounds, carbon monoxide and carbon dioxide, then the ratio of weight of the element, oxygen, here also oxygen, that combines with fixed weight of another element, carbon, bears a simple whole number ratio. What is the ratio here? 1 is to 2. Similarly, I am writing another example. See to that hydrogen combines with oxygen. You know, hydrogen combines with oxygen can form two compounds. First one is water and second one is H2O2. So let me write both. Hydrogen combines with oxygen to form H2O. Hydrogen combines with oxygen to form H2O2. See, first compound is H2O, second compound also H2, but O2. In these two cases, you can see that, like in the earlier case, whose mass is fixed, carbon mass is fixed, but in this case, whose mass is fixed there, hydrogen mass is fixed. But whose weight differ? Oxygen weight differ. Let me find the ratio of this weight of oxygen in first one is to second one. So what you get, you will be getting 16 is to 32, which will be equals 1 is to 2. So what is meant by law of multiple proportion? When two elements combine to form more than one compound, then the ratio of weight of one element that combines with fixed weight of another one bears a simple whole number ratio. So this is what called as a law of multiple proportion. So let's see one of the example for law of definite proportion. See, I had given a compound MO2. It's a metal oxide. And there we have a weight ratio 50 is to 50, or 50% metal and 50% oxygen. And we are given with another metal oxide MXOY. The percentage of metal right now 25% and oxygen is 75%. We need to find the formula of this particular metal oxide. So what to do? How we can solve this problem? See to that. See, here I am writing once again, what is the weight ratio? Weight ratio is 1 is to 1. So in the first metal oxide, weight ratio comes as 1 is to 1. Then atoms ratio. See, I have written here weight ratio. Similarly, I am just writing next atoms ratio. See how many atoms are there present. So I am writing that 1 N is present, 2 oxygen is present. So I can write atom ratio is 1 is to 2. So here, to solve this particular problem, we need to read this as, for 1 you get 1 here, for 1 you get 2 here. So let's see to the next one. What is the weight ratio we are provided with? 25 is to 75. Or else let's take the symbol ratio. What is the symbol ratio? It's 1 is to 3. So the ratio in this case 50 is to 50, so that we got 1 is to 1. But in this case we have 25 is to 75, means we have a 1 is to 3. See, then we need to find out atomic ratio. See, for here 1 is 1 for 1, here 1 for 2. Similarly, if you have 1 here, you need to write 1 atomic ratio. And here 1 for 2, then what you need to write there? 3, 4, 6. So we get the formula of the compound M1 and O6. In that manner, you get the formula of the second oxide MO6. See the problem once again. See, we are provided with the first metal oxide MO2, where we have 50% metal and 50% oxygen. And now they are asking what is the formula of second metal oxide with 25% metal and 70% oxygen. So to solve this, what the approach we have considered? See, what is the weight ratio? 50 is to 50, or else you can say 1 is to 1. And what the corresponding atomic ratio? For this particular weight ratio, we have atomic ratio 1 is to 2. Why 1? Because we have only one metal. Why 2? Because we have 2 oxygen. So 1 for 1, 1 for 2. Now by carrying this, we are coming to next second oxide. In second oxide, we know we have a weight ratio 25 is to 75, which means 1 is to 3. So 1 for 1, so we have 1 for 1. 1 for 2, so we have 3 for 6. So we got the atomic ratio from the weight ratio. So we have substituted and we got the formula of second oxide MO6. This is the way how we need to solve the problems based on law of multiple proportion. So now we are left with the 2 more laws. First one, Gay-Lussac law of combining volume, and the next one is Avogadro's law. So what is meant by Gay-Lussac law of combining volume? First and the most important, this law is applicable only when gaseous reactants and products are involved. See, I am just considering one reaction here, N2 reacting with 3H2, you get 2NH3. See, in this particular reaction, you know, nitrogen is gas, hydrogen also gas, ammonia also gas. So I can say that nitrogen gaseous reactant, hydrogen gaseous reactant, ammonia it's a gaseous product. So we know how normally we read this equation. We read like 1 mole of nitrogen combines with the 3 mole of hydrogen to give a 2 mole of ammonia. But according to Gay-Lussac law, when or under identical condition of temperature and pressure, when the volume of nitrogen is 1 liter, then the hydrogen volume that combines with this is 3 liter and that of ammonia is 2 liter. Then what the volume ratio? Simple whole number ratio we can write 1 is to 3 is to 2. So according to Gay-Lussac law, when gaseous reactants are involved, then their volumes base a simple whole number ratio. In a particular reaction, when gaseous reactants and products are involved, their volume base a simple whole number ratio. Let me consider another example. See to that, 2H2 plus we have a O2 gives you 2H2O. Let's imagine all these reactants and products are in the gaseous state. Then I can write here, this one is gas, second one also gas, last one also gas. So what is the simple whole number ratio here? Volume ratio 2 is to 1 is to 2. This is what called the Gay-Lussac law of gaseous volume. So now let's see what is meant by Avogadro's law. Actually Avogadro's law is nothing else. Under identical condition of temperature and pressure, volume directly proportional to number of moles. Or else, what we can write there, V1 divided by V2 is equal to N1 divided by N2. where small n represent number of moles. Or else, you have to take number of moles given weight by molar mass. So that what I can write there, V1 divided by V2 is equal to W1 divided by M1 into M2 divided by W1. This is what we have Avogadro's law. So we have discussed about all the 5 basic fundamental laws, and definitely in the coming section we can include more problems, and we'll be discussing on problems on next class.